Right, over to you, Laura. Thank you very much.
Thank you. Right, I will share my screen. And I can still see you. That's brilliant. All right, well, first things first, just thank you for inviting me along to talk. I know there's been some really great topics that you've had in the past, so it's really, really kind of you to allow me to come and talk about geoarchaeology and geoparks, which I could speak about all night, so I'll try not to keep you too long. So just to give you a feeling of what to expect from me, this is how I'm laying out my talk. So I'll introduce myself, talk a bit about geoarchaeology and some of the sites that I'm aware of and some sites that I've worked on, talk about geoparks, and then some ideas for collaboration and future ideas too. So first myself, my name's Laura Hamlet and I'm the manager for the Northwest Highlands UNESCO Global Geopark, but I'm also an honorary fellow at the University of Stirling, where I studied geoarchaeology for my PhD. So what is geoarchaeology? It is the clashing of earth science methods to answer archaeological research questions. So earth science is obviously a broad church. There's lots of different disciplines in there, everything from soil science to geology, as you've already explained, Susan. But it helps archaeologists to understand landscape scale processes as well as site formation processes. So these are some of the typical questions that are asked by geoarchaeologists on archaeological sites, things like, what was the environment like? What agricultural techniques were used here? Is this a collapsed roof? Was this an animal pen? Is this reddening due to burning? What materials make up the midden deposits? And what materials make up anthrosols beyond the settlement sites? So anthrosols being soils that have been affected by humans in some way. So I'd like to talk about some examples. Now, a lot of these are sites that I haven't worked on because I wanted to kind of keep it to the Highlands if possible. So there are some sites here that I've worked on myself, but they tend to be in the islands. So that'll be good for Kate from the West Niles. So starting with the Claver Kens in Inverness. This was a site worked on by researchers from Stirling University in 1994. So this was Ian Simpson, who was my PhD supervisor at Stirling, and Donald Davidson, who used thin section micromorphology to reconstruct the landscape predating the construction of the monuments at Claver. And this technique involves the recovery of soil or sediment samples using cubienitins, which are just here. So it's partly borrowed from petrological analysis, so a technique used by geologists and soil scientists to identify the mineral composition of rock samples. Using this technique on soils beneath the southwest chambered cairn at Claver, Ian and David discovered a podzol soil developed on a fluvio-glacial sand deposit. Now, these soils tend to occur in forested environments, so they're able to say something straight away about what the environment was like before the cairns were built. And in horizons 1 or 2, I don't know if you can see my mouse here, this square diagram is a thin section diagram, and in horizons 1 and 2 you can see a typical podzol, whilst slight differences in horizon 3 were indicating new material containing charcoal and heated stone was introduced to the site. So they were able to see features in the thin sections called laminated pedifeatures, which are diagnostic of cultivation activity. However, the stoniness of the soil likely made cultivation quite difficult, and there was a loss of nutrients through the free draining nature of the soil. So the site was abandoned for cultivation sometime before it was burned to clear vegetation ready for construction of the cairn. So prior to construction, the ground surface was also raised up through the dumping of soil material, which they could then see in thin section 2. And they revealed that the ground was prepared in different ways under different sections of the cairn, with finely mixed mineral material used in some areas. Robertshaven, another site in Caithness. This was the spring of 1992. A survey at Robertshaven confirmed earlier reports that a midden dominated by well-preserved fish bone and tentatively dated to the late Norse period was eroding into the sea. Geoarchaeological support from Ian Simpson again was engaged to answer questions like, what materials formed the middens? How quickly did middens accumulate? Was this an industrial or a domestic site? And was it continuously inhabited? Someone's in, hooray. So 2 areas were investigated, Area A and Area B, which I hope you can see there. It was evident from wind-blown sand deposits at both locations that the midden formed within an active dune system. And as at the Clavicens, thin section micromorphology was used to investigate sediments microscopically. Wind-blown sands were shown to be mostly calcareous, but also containing quartz, feldspar, biotite, compound quartz grains, sandstones, and siltstones, which were all consistent with the local old red sandstone and Caithness flagstone geology. However, by measuring the size of these minerals and associated materials, it's possible to see that some arrived into the midden by aeolian wind-blown processes, whilst others were carried to the midden within burnt grassy turfs or peat. On considering whether the middens develop sporadically or continuously, a number of features diagnostic of surface weathering were analysed and caution was advised due to the possibility that they'd been inherited from turfs cut and transported to the site from elsewhere. Textural and excremental pedifeatures such as isotropic clays coating and infilling the pore spaces of the sediments in thin section in Area A were associated with short-term, possibly seasonal movement of fine material from unvegetated surfaces prior to the surface being buried by further deposition. In contrast to Area A, micromorphological evidence from Area B suggested that midden deposition were virtually continuous. Soil thin sections also revealed evidence of burnt and unburnt grassy and peaty turfs collected from a variety of local sources. They also suggest that there may be a component of herbivore dung in the deposit, evidenced by calcium oxalate spherulites near the top of the stratigraphy in Area B. This evidence, combined with the recovery of pottery and carbonized cereal grain from excavated samples, convinced the researchers of the existence of an associated settlement, either permanent or seasonal. Therefore, Ian Simpson was able to conclude that fish processing waste and other midden material, perhaps to mask the odour of the fish, was deposited in Area A seasonally, whilst burnt peat and other domestic rubbish accumulated continuously in nearby Area B. Ian was reluctant to rule out the possibility that cycles of deposition represent shifts in the focus of deposition over what must have been quite a considerable area of midden. At least 28 metres were exposed in the wave-cut bank. So although it wasn't possible to state how long the middens took to accumulate, they were able to significantly narrow down the possible interpretations of the site and set the stage for more comprehensive comparative studies. This site is one that I'm sure many people will be aware of. At Langwell Farm, a woman's body was discovered by chance in 2009. What was remarkable about Langwell Kist was the preservation of the body and the organic grave goods that were with it. Soils in and around Langwell Farm are peaty glaze and podzels, which were formed on stony till deposits derived from schist, gneiss, granulites, and quartzites. The natural pH of these soils today would be expected to be extremely acidic, and hence bone and organic matter preservation in such soils would normally be very poor. The kist was located on a rise, but close to the River Oikel, so may have been affected by fluctuating groundwater too. So it was fairly astonishing to find such well-preserved organic remains, and there were many questions to be answered, both on Bronze Age cultural practice, but also on how the remains had survived. Historic Scotland funded a detailed phase of post-excavation analysis, and Claire Wilson from the University of Stirling was called upon to conduct SEM, EDS, and bulk soils analysis. The team wanted to know more about the white powdery material associated with the remains to understand the biological and chemical processes that happened in the kist since the burial. The samples analysed were from the disturbed upper burial matrix material overlaying the body and around the head area. The white residue in all the samples was shown under the scanning electron microscope to be highly crystalline. The carbon and oxygen ratios of all the samples suggested that they were carbonates. The high concentrations of calcium, phosphate, and sulfur indicated that these carbonates originated from the decay of the body rather than being naturally occurring soil minerals. The white residue, therefore, appeared to be the product of bone recrystallization, producing carbonates and phosphates derived from bone apatite. The sample from the head area contained fibers running through some fragments of white residue, and under the scanning electron microscope, these were clearly identifiable as hair fibers and not inconsistent with cattle hide. The local soil conditions at Langwell Farm are likely to have been highly acidic, but the pH measurements of bulk soil samples taken from around the body showed that the conditions within the kist were actually milder. The kist was built by cutting into mineral soil, which was also used as a capping deposit. The composition of this soil was influenced by the local geology, Lewisian gneiss, moin schists and quartzites, which, while still acidic in nature, are milder than the present day peat, which did not begin to form until around about 800 to 450 BC. The capping of the kist would have subsequently protected the burial environment from further acidification and helped to create a quasi-equilibrium more conducive to bone preservation. Phosphorus occurs in soils in oxidized phosphatic forms. It's released from the body and bone via decomposition and is mineralized by the actions of soil microbes. These inorganic phosphates are predominantly immobilized in the soil through sorption to clay, iron and aluminium minerals. The clay content of the soils from Langwell Farm kist varies, but it's sufficient to bind with at least a significant proportion of mineralized phosphate, and phosphate concentrations are consistent with those from other grave sites. Phosphorus concentrations in clay, iron and aluminium minerals were highest in those deposits that were in direct contact with the body. This is because of the action of soil microbes decomposing the bone. Total phosphate analysis showed that the context beneath and below the body, so the context above and below the body had enhanced phosphorus levels, which indicated that there was vertical movement of phosphorus in both directions. And we know this pattern is consistent with occasional waterlogging from groundwater, which may have assisted the preservation. The principal investigator was able to use this evidence alongside other analytical results to hypothesize that the burial may have actually been deliberately timed to coincide with ground thaw and waterlogging. To the Links of Northland. The Links of Northland is a Neolithic and Bronze Age settlement on Westray in the Orkney Island group. In 2008, the site was undergoing rescue excavation due to the deflation of the dune system that had been protecting it. The site managers originally approached the University of Stirling to ask about a particular section through a field system. They wanted to know whether windblown sand had been continuous through the whole period of occupation, or whether any particular materials were evident in the soil layers they found sandwiched between the layers of windblown sand. Preliminary analysis revealed the systematic use of animal manures in cultivation activity in Orkney might have actually been earlier than previously thought. So the site was revealed to be extremely important to prehistoric Orcadian archaeology, and I had the privilege to work on it for my PhD research. I worked with archaeologists to help answer lots of questions. Here are some of them. What was the difference between the lower and upper soils? What kind of activity was happening in this field system? How do all the different layers of activity relate to each other? Was this an animal pen? Is this midden homogeneous? What domestic material from the settlement was used as fertilizer? So the first method we employed was detailed auger survey. This identified a few discrete areas of anthropic activity superimposed on a general brownish loamy clay, which in turn had developed over a natural glacial till. Orkney is covered in a thick layer of boulder clay, and this was later shown by the SEM-EDX analysis to have been a component of building materials when mixed with midden. Following the auger survey, I worked with a geologist from the British Geological Survey to create a subsurface model to help understand the differences in all the different layers and how they joined up to identify good places to remove the surface sand and do some further investigations. So this image here on the left is all of the different auger points, and the blue lines are the potential kind of field banks. And then this image that's superimposing the satellite image is an example of the subsurface models that we're able to create using the auger points. Cubiana tins were then deployed for thin section analysis in the field system and throughout the settlement site. which was covered in midden material for comparison. And we wanted to understand what the midden was, but also how it varied around the site and whether any of it had ended up in the fields, and if so, what and from where. SEM-EDX analysis was helpful again to understand the elemental composition of midden material, to inform statistical analysis, to test our hypotheses on midden distribution. So I've mentioned SEM-EDX analysis a couple of times. This is the scanning electron microscope, which allows you to really zoom in very, very fine detail and analyze the actual elements that the sample is made up of. So here were some of the key findings in black and white. See what I did there? Vegetation clearance is evidenced within the underlying soils at the Links of Northland. Spatial analysis of soils associated with Neolithic occupation demonstrate that they were well preserved over a wider area than anticipated. Early agricultural practice, sorry, that's like zoom too far. Early agricultural practice involved the tillage of cleared ground with the addition of hearth waste and incorporated aeolian sand and brown earth to create a fertile tilth. Animal manure was burnt as fuel in domestic hearths during the Neolithic and Bronze Age. The potential nutrient value of both animal manure and anthropic sediments was not exploited to maximum potential by the communities in the late Neolithic and early Bronze Age at the Links of Northland. The archaeological material known as cramp was incorporated into anthropic deposits around the settlement area, which is quite unusual. Yellow clay found at the Links of Northland was used in things like roof construction and wall construction, and it's actually processed glacial till. Interior floors were accumulated through occupation, and organic residues might hint at a thresh-like flooring. In situ burning activities in anthropic sediments alluded to maintenance activities, including hearth rakeout and burning grassy material, which may represent floor coverings or bedding material. Animal stalling and related maintenance is associated with the later Neolithic and earlier Bronze Age part of the settlement, which is quite a lot earlier than we thought people were actually carrying out this practice. Then sand accretion, which was blown onto the site from the nearby beach system, necessitated a change in land management activity. Basically, the soils that people were using to cultivate were completely buried in sand, and so they had to start again. And this happened a number of times. Anthropic sediments covering the Neolithic settlement were cultivated prior to the sand inundation, and anthropic sediments were redirected into zones of windblown sand to establish cultivation zones. So now we're going to zip over to the Western Isles to another site that I've worked on. This is a site where soil science and geological techniques have helped understand more about the site formation process. So Mike Parker Pearson contacted the University of Stirling to ask whether the samples he'd taken for thin section micromorphology represented a collapsed roof or floor layers. So we got to work. The earliest deposits under investigation were from structure 2476, or a cigar-shaped passage structure with a thick floor layer but no hearth. This was constructed by cutting a gully through two earlier structures and appears to have had an entrance which sunk below the ground level. The floor deposits within the structure were described as lacking the compaction associated with other structures found at Cladhallen, and so two samples were recovered to investigate whether these deposits were floor or roof debris. Two roundhouses were also selected for sampling, the middle and the northern structures, excavated in what seems to have been a terrace. The middle house was built with a sunken floor and dry stone walls and a sand core. It was sunk deeper than both of the adjacent houses. The floor deposits in the middle house were in places greater than ½ metre deep, with visible banding and microstratigraphic variation. The primary floor layer was associated with a hearth that was clay lined and a shallow stone water tank. The sediment variations visible in the floor layers throughout incorporate deliberate constructional elements such as turf and peat ash, along with floor treatments, potentially reflecting routine raking and spreading of fresh sand. Archaeological analysis identified patterned spatial distribution of artifactual and environmental evidence for the distinct usage of space within both houses, suggesting that the southeast quarters were for cooking and the southwest were for working and the north half perhaps for sleeping. 5 samples were recovered from these areas for thin section analysis to investigate the floor composition, its usage, and whether or not any bioturbation had occurred. An extra sample was added to this set to establish the source of sedimentation recovered from the laminated lenses infilling the stone-lined water tank. So the earliest floor layer in the northern house was laid directly onto the bottom of a flat-bottomed house pit. It had an associated hearth and several shallow pits and stake holes. Beneath this floor were 2 composite skeletons. A fill layer sealed the floor, and a series of 8 stake holes and a pit were cut into it. The wall core of the house was also widened eastwards around the same time, and a second surface was laid upon it. It was characterised by a domed surface with a hearth positioned at the highest point. 30 post holes, 2 pits and a stone hole were found in association with this surface, and a clay-lined basin. Samples were recovered to identify any occupational surfaces and the constituents which represented formation and intensity of use. Organic sediments from house interiors at Clodhallen vary in their preservation. A chronology based upon a hierarchical relationship between sediment features can be proposed. The sequence of occupation surfaces and functions is as follows. There was an initial construction of a domestic beaten floor on clean quartz sand with a cyclical buildup of occupational debris and turf, sand and hearth deposition. Both of the hearth samples contained a wide variety of fuel residues that might indicate an opportunistic approach to exploitation of resources. Evidence for metallurgical activity may be provided by calcium carbonate and glassy slag features in the floor of the middle house. This domestic and industrial activity was then superseded, and the occupation surfaces were reworked by herbivore and omnivore activity. These floors at Clodhallen appear comparable to those recorded in the post-medieval sea stack site of Donation, where peat and hearth minerals were laid down as rough floor coverings within stone and turf-built structures. Indeed, charcoal and ash spreads on domestic floor surfaces of turf buildings are well documented in the North Atlantic, although until now, not earlier than the Viking Age. Which then brings me on to another famous site in the Highlands, Clachthol Broch, recently excavated by AOC as part of the Clachthol Broch project with historic Athen. I didn't work personally on this site either, but I'm aware of the very good work by AOC's team and the website recently launched by AOC and Historic Athen. That's www.clachtholbroch.com. As part of a suite of analysis to better understand the site, geoarchaeologist Lynn Roy studied the floor deposits at Clachthol. These deposits were remarkably well preserved, having been sealed beneath a layer of burnt material associated with the deconstruction of the broch. Sediment thin section analysis was able to answer questions like, what materials made up the floor? What kind of activity went on here? What fuels were used in the hearth? And is there evidence of a collapsed roof? In this thin section, Lynn found that the floor was made up of rushes, reeds and grasses, with sands, charcoal and small gravels possibly added to harden them. As we saw at Clodhallen, with many North Atlantic floors, ash was a component of the flooring, perhaps added deliberately to keep it fresh. Sharp boundaries between floor layers show that it was well maintained and periodical sweeping was carried out. But even the best cleaners can't hide from micromorphologists, and Lynn found small fragments of animal dung, both from rodents, dogs or pigs, and herbivores. Wood peat and dung were also found as fuel residues associated with the hearth, and frequent changes in the fuel type found in layers might have indicated a seasonal availability or the requirements of different crafting activities. Most intriguingly, Lynn found that the burnt layer sealing the floor deposits was capped with grassy turf material that seemed to have collapsed directly onto the burning floors, suggesting that the roof may have been at least partially constructed using turf cut from the surrounding landscape. But geoarchaeology isn't always about reconstructing past events. Dave McCaughey at the University of Stirling has also been studying the building materials at Clachthol to attempt to predict future climate change impacts on culturally important structures like Clachthol Broch. David's been researching to understand how the Torridonian sandstone, the main building material at Clachthol, has weathered in the past and how it will continue to weather under a number of possible climate change scenarios. Using thin section analysis, X-ray diffraction and scanning electron microscopy, which are all techniques borrowed from geology, the building materials were compared to samples of Torridonian sandstone taken from the local bedrock geology at Clachthol. Samples were exposed to simulated weathering experiments in controlled environment chambers at the Stirling University, and experiments were informed by UK Climate Projections 2018 data. In his first experiment, McCaughey exposed samples in 1 year of temperature, humidity, precipitation fluctuations anticipated to happen in northern Scotland to 2055. Then he exposed samples to 30 years of seasonal climate change, temperature, humidity and precipitation fluctuations anticipated in northern Scotland between 2025 and 2055. Finally, a control was run for each experiment, whereby samples of the same type were exposed to repeat 2018 fluctuations in order for the effects of climate change to be disentangled from the weathering effects that are occurring at present. From the comparisons made between samples exposed to different treatments, specific decay models were generated, giving insight into how culturally significant Torridonian sandstone will proceed to weather in the coming decades. David's almost finished his PhD work, so we're going to have to wait for his final conclusions. So now on to geoparks and why they're relevant to geoarchaeology. I'll just grab a quick drink. UNESCO Global Geopark management models are particularly suited to geoarchaeological concepts, viewing society and culture as part of dynamic and holistic ecosystems. And as I hope I might have convinced you, geoarchaeology uses earth science methods to answer archaeological research questions. And their applications are broad and help us to understand how people interact with their environment and the resources available to them. Bringing this into the present day, we can consider how we might look around us and make the most of our natural and cultural heritage to build sustainable communities in fragile economic areas. The UNESCO Global Geoparks programme aims to support communities to fully appreciate their landscapes and the opportunities available to them. In the Highlands, the Northwest Highlands UNESCO Global Geopark follows this model, has been the catalyst for community-led research and geotourism initiatives. All geoparks must have geological heritage of international value. They must have a management structure and a management plan to go with it. They must have branding and visibility and be part of the global geoparks network. Our geopark covers a 2,000 square kilometre area of the Northwest Highlands. A section of it is in northern Westeros, which is Coigach with Achiltabui at the bottom there. And then the rest of it is in Sutherland with the communities of Assynt, Skerry, Kinlochbervie, Durness and Tongue. Our vision is to be a thriving and sustainable rural economy, capitalising on the assets and people of the geopark in partnership with local government, relevant agencies and local businesses. We do this through our sixth objective, which is develop, promote, engage, manage, conserve and finance. And I'll explain a little bit more about that. So with the develop and promote objectives, we tend to get involved in projects to deliver this. And one of the projects that we're almost finished delivering just now is part of the Coigach Assynt Living Landscape Partnership. And it's a sense of place project, which involved working with the communities of Assynt and Coigach in some absolutely wonderful workshops and surveys and continuous consultation to talk about what it's like to live in Assynt and Coigach and the kind of messages that we want to communicate to the outside world. So this is partly to counter the kind of top-down marketing that might come from Visit Scotland about what it's like in these areas. But it's also to communicate to anybody who might be wanting to learn about the area. Perhaps they would like to move to the area. Perhaps they're writing some interpretation or something, or a book or something like that. So we want to help them by giving them a sense of what it's like from people who've lived there. That work then fed into a walker's guide to Coigach and Assynt, which is a guidebook that's about to be published next month. A toolkit for local businesses to use to help stimulate their own websites, things like photography. We've been working with 13 artists to produce photography, poetry, paintings, you name it. It's all going to be part of the Geoparks website very soon. But we've also been working with the local guide on a mobile phone app, which you can use when you're cycling or driving. And when you reach a point of interest, it'll bing and it'll tell you about the place that you've arrived at. Under our conserve objective, we've been working on another project, which is a soil fertility project, which is another part of the Coigach Living Landscape. So this is all funded by the Heritage Lottery with other partners such as the Garfield Weston Trust, and this one in particular is the University of Stirling, who are match funding it. And this work was, it was a really fun project actually to work on. So it's with the University of Stirling. There's a PhD student who's really looking into the cultural soils, all of that work that we've been talking about with other sites in the Highlands and Islands, looking at the soils and what fuel residues you might find in them from midden material being used to enhance the nutrients available to plants. And the PhD student is looking at these soils to try and see what they can tell us about future nutrient legacies as well. We also, oh, hang on, I'll get onto that bit in a minute, getting ahead of myself. So these are the total phosphate maps, and our PhD student, Louisa Cameron, is trying to figure out if the soil nutrient content is related to the background geology, settlement, human management of soils, or a combination of all three. So this is an element map for the phosphorus, but she's also going to look at other elements and see how they correspond to the underlying geology, the bedrock geology, as well as the quaternary geology that's come in through glaciation, and the settlement sites around the area, as well as the management of soil since the sites were cleared or abandoned. As part of the project, we also followed our engage objective. This is to work with anybody that'll listen to us, that includes you guys tonight, to talk about the work of the Geoparks and the model and how we can help with sustainable development. And this is us working with the high school in Ullapool to take the higher geography students out into the field to work alongside the PhD student to help with the analysis. And this then led to them having some really super cool soils projects for their geography hires. We also engage with the general public through geotours. So this a bunch of folk in their high-vis vests there are standing at the roadside looking at some fantastic geology that you can see just right by the road as part of the rock route, which runs from the Ullapool in the south of the Geopark all the way up to Tongue in the north. We have a small visitor centre, the Rock Stop at Ullapool, which you can see just poking through the trees there. That is overlooking the site of the Glencoe Thrust, which is one of the most photographed pieces of geology in the country. And we also have landscape visitor interpretation and orientation points called the Geopods, which my son's modelling there for me. Small child for scale. You can see there's a map of the Geopark there, and on the other panel it says Pebble Route 2. Pebble routes are driving routes which take you off the main road down into some of the smaller communities so that people spend more time exploring. So some ideas for collaboration. In the Geopark, we do have local knowledge of where certain raw materials outcrop. The British Geological Survey mapping is absolutely stunning. It's really beautiful mapping. It's very detailed, but it can also be a little bit overwhelming if you're not used to working with geological maps. So the idea that I had around this is perhaps the geologists that we have that work with us in the Highlands are they're very skilled in the local knowledge, and so they might be able to help understand the kind of links between the artifacts and the source of material like steatite or limestone. And through our links with the University of Stirling, we're interested in getting a better understanding of the underlying soils, how geology affects them, how human activity affects them. The Highlands are underrepresented in the North Atlantic in these areas of research, so it would be really fantastic to fill some of the research gaps and link up with other countries, perhaps Iceland, Norway, and of course the islands as well. So for some future ideas, mapping out resources from existing geological and soils maps. Perhaps is the way that earth science can engage with human culture, both past and present, is sometimes surprising. So geologists, could be available, for example, for archaeological events that might be happening. So could we team up? So I'm just wondering, is this what you were expecting? Is this the kind of collaboration that you really imagined, or did you have something else in mind? So these are my ideas, just kind of thrown onto a page. But it would be really great to maybe have a conversation. So I'll stop talking, leave it there. And if there are any questions or anything, I am very happy to answer them. I've got a thank you slide. But I can keep my slides up with the ideas for collaboration. But I'd love to have a conversation about it.
That's great, Laura. Thank you very much. Just thinking, I can't see the people who are going to ask questions if I have your slide up, unfortunately. So people are going to have to put their questions into the chat in that case, or after a little bit, we can come off of your slide perhaps and just sort of see, so people can do that as well.
Well, I can do that just now if that's easier.
I think that, yes, I think, you know, everybody focus on that, because you've raised so many interesting questions, interesting possibilities here. And it'd be great to sort of explore a bit.
Okay. Well,
go ahead.
Yeah, I was just going to say that those are the two kind of main ideas that I had, like mapping out the resources of existing geological maps and soils maps, but also perhaps a cheaper and easier option is just seeing if we can match up geologists with archaeologists, both at events and maybe even excavation. But it's yeah, it's two ideas there for discussion.
Does anybody want to take up this challenge that Laura's laid down? If not, I can say, well, I have two right there. I mean, you've hit two things on nails on the head that I've been interested in. One of which is mapping up the geology and trying to from existing. I want to know where the steatite is outcropping, because we have this feeling that some of it's coming from Shetland, but it'd be wonderful to have a collaboration where we could get that to find out where we're getting these outcrops, which are then used from the Iron Age onwards, and perhaps even earlier. So yes, absolutely, yes, there's so much potential on that. The other, should archaeologists be working with geology? Oh, absolutely. I mean, at the moment, I can cite a case where we've been, a group of us volunteering at Inverness Museum, and we've been looking at some of the material and helping to accession it. And a geologist has come along with it, and it's been absolutely fantastic to have somebody there at the same time. We're constantly taking over the material and showing it to him, where he's giving his insight and said, no, that doesn't outcrop anywhere near around here. So yes to both. I don't know if anybody else has any other ideas or thoughts of where this could go.
Susan, if I could just make a couple of comments. I mean, first of all, just following up on your sort of where did it come from, which of course many archaeologists do ask. And I have sort of have vaguely a foot in both camps here. And so as a result, I'm not really an expert in either. But one of the things that always bugs people is when flints and so on are found, because of course the question is, where did it come from? And there are very few sources of flints when we come north in the Highlands. And so I'm not necessarily, Laura, expecting you to just answer that, because that's just an impossible question almost. But that sort of issue is one of the things that that emerges. And the other area that I see the overlap between the two is, I think you hinted at it when you said formation of the landscape, because often, you know, when we look at an area, I mean, you have concentrated very much on what I would see as the sort of small scale things of looking at a site and looking at it. But actually, in many cases, what archaeologists do is they look at the sort of the landscape, the environment, where settlements are and all of that sort of thing. And in many ways, that was what drew me towards trying to study a little bit about geology, because the geology has such an important, you know, effect on that. So I've not really got any particular questions, but I just thought I'd throw in those two sort of lines of thought.
I could actually talk a bit about the flints if anybody's interested and their provenance. Can you hear me okay?
Yes, I mean, to introduce, this is Andy Moffat, who's been helping us at Inverness Museum. So sorry, Andy, I hadn't even realized you were joining us tonight.
Yes, I'm here. I was in Orkney just recently, and I went across to Skara Brae, and I noticed they had some Cretaceous flints as exhibits there, and I was a bit curious as to how they got there. The next day, I went and saw a friend, Dr. John Flett Brown, who's a geologist who lives in Stromness, and he told me that it's quite simple. He's collected lots of flints off the beaches. Simply, the Cretaceous chalk outcrops in part of the seabed in the central North Sea, and have been brought across by ice during the Pleistocene Ice Age. And so I guess, you know, that's probably one of the main sources of where they got the flints from, perhaps rather than trade.
I love the idea, Andy, of getting everybody together in a room, and you could almost have archaeologists who are saying, where does this come from? And geologists who can literally draw it on a map in front of them. That would be so, so cool. And then we could have a kind of resource map of the Highlands and Islands.
Well, I was doing some of this at Inverness Museum until the pandemic came along, and that's put paid to that for the time being.
Yeah, that's the problem, isn't it? Yeah, when we're allowed to physically meet again, like that, it might actually be like a real welcome
Yes.
activity to do. Sense of purpose to get together for something.
Sounds like a great
fact,
idea, something for the future, yes.
When I was in, before I was in Auckland, I was in Shetland a few weeks ago, and on the island of Fetla, I went to the Heritage Centre, and they got some incredibly rare rocks there, which mostly only occur on Fetla, which have been used as stone axes, and they hadn't even been identified, the lithology. It's actually a rock called rhodingite, which is associated with serpentinite. So that was quite an eye-opener. I've never seen that used as stone tools before. And you can actually find the unworked material on the beaches. So I guess they just found something suitable that was hard, dense, and fashioned it into stone axes.
Laura, we've got another question. I'm going to move us just briefly over to geoparks, because we've had a question. What are the diagnostic features which make an area a geopark?
So in terms of like the actual geology, geoparks have to be unique. So if you have very similar geology to another geopark, then you would have to have like, well, it would be very difficult for two geoparks to have like similar geology. So it has to be kind of unique and international on its significance. So in the Northwest Highlands, there's actually quite a number of features that make the Northwest Highlands special. One of them is the Moyne Thrust. So this is something that was used by geologists actually in the late 1800s, early 1900s to demonstrate mountain building features. So the features that you can see in the Northwest Highlands are actually the kind of roots of an ancient mountain chain. And the geologists use that to demonstrate that in other parts of the world, where you get mountain chains like the Alps and the Himalayas, the same processes are going on there. They're just like much they're just much but the word has gone from my head. They are much deeper beneath the mountains. So this was something that helped us to understand how mountains are made internationally right across the world, and it happened in the Northwest Highlands. So that's one of the reasons that we're particularly important. But we've also got some of the oldest rocks in Western Europe, the Lewisian gneiss. And then some of the unconformities that rest between that and the Torridonian sandstone. I could talk about this all night. There's some like pretty cool rocks in the Northwest Highlands, and that's why we were allowed to become a geopark, recognized by UNESCO. But in terms of like the other parts of what makes a geopark, it's also that management plan that's really important. So you've got to have the will and the appetite as a community, whether that's a community of interest or a geographical community or a partnership between public agencies, whatever it is. You've got to have the will to get together and say, yep, we're going to manage this landscape as a UNESCO Global Geopark. So that's what they look for as well. So those are kind of the two main areas that would allow you to become one.
Thanks, Laura. We've also had a question from Alison Wright, which is going back to our previous discussion, is perhaps could we hold joint practical trainings? So for example, their interpretation of minerals in thin section, Or incidentally, how do you make thin sections from unconsolidated materials? So sort of two aspects to this.
Ooh, okay. Do you want me to answer that question about the unconsolidated materials?
How long do we have?
Well, just like sort of super brief. The cubiennitins that we saw a couple of pictures of there in that presentation, they're kind of about the same size as a tin of sardines, mackerel, and you would push that into the unconsolidated section and then pull it out very, very carefully and put a lid on it and treat it very, very carefully until you get it back to the lab, at which point you replace all the moisture by acetone exchange and set it in resin. And then once it's in resin, you can then file it down to about 3 microns thick and mount it on glass so you can look at it under the microscope.
And do you think this is, could we hold, is this something in a joint training practical sessions on this? Would that be a possibility to get more people involved with it?
That would be super fab. So yeah, like I've been to workshops before where you sit with microscopes and everybody kind of talks about what they can see. So yeah, I think that would be possible.
But you need a lab, so we would have to have access to a lab, or do you?
It's more the equipment. Petrological microscopes are pretty transportable. Right. It's yeah, it would just be getting access to them.
So the background here, I'm sort of, my mind is thinking maybe we should think about it at a future Highland Archaeology Festival to have a sort of make an event where we could have perhaps trial out some of these joint sessions.
That sounds really fun.
A question or a comment from David Longstaff asking, says, interesting talk, thank you. With reference to the Torridonian weathering experiments, I can understand how you can vary temperature and humidity, but how do you include the effects of the passage of time? Is one batch of rocks subjected to present day conditions and another batch subjected to forecast 2055 for the temperatures, etc.? Surely you need many years of this experiment to have valid results.
I can't answer that question. That's one for David. David McCorkey's PhD. I am merely just the messenger on that one, I'm afraid. I wish I could answer more, but the research does go up into the Stirling University repository, so it should be available to see.
Other questions there? Nobody's jumping in. I have so many questions that your talk has brought up. I mean, it seems to me that basically manuring seems to be one of the things that we really don't understand enough about. And because it's people making use of soils that are not necessarily optimum and being able to survive. And it seems to me that these techniques are absolutely vital for understand and also understanding fuel. What are you using? If it's trees, what trees are around? Where are you cutting them down? Do you have woodland management? So I suppose my question that comes on this is, how many excavations plan this in ahead of time? And how many perhaps do it as an afterthought? And should this be more mainstreamed?
Well, I have to say 100% of the ones I've worked on have done it. But a lot of them, yeah, like a lot of approaches to the lab at Stirling University tend to be retrospective. So someone's thought, oh, I know, I'll stick a thin section here. I'll stick a cubientin in here just to find out what it is. But actually, if you had somebody on site, then you could plan it much better. So you can actually look at the section and say, actually, here is where you're going to get a really good result. So yeah, I think definitely it would be great to have this kind of planning on site.
Thank you. That's, yeah, yes, optimal. Gordon, you're muted still.
Just to add that there's a sort of room for both in a way, because in the case of the Brock project at Clactol, we had quite a lot built in. But then the opportunity of David coming and doing some of his research within that sort of general area and looking specifically at the rock came in as something from outside. And we've had other sort of interest in the project, which has resulted in further work being done by other people. So it was a matter of the two under those circumstances. So I wouldn't want to rule out either one or the other. But having it built in for a start at least means that you're getting the basic information out.
Yeah, it's a tool, isn't it, Gordon?
Yeah.
You know, it's something that's good to have in your toolkit, no matter what. And certainly, yeah, like some of the sites I've worked on as well, it's been a similar approach. There's been a planned approach to some of the contexts. But others, it's just a case of, have you got any spare tins? You stick one in there and see what it is. And that's great as well. You know, you can learn a lot that way as well.
Yeah.
Any other questions that anybody has for Laura? Well, I think I'll just say, yes, thank you for such a far-ranging and interesting talk. So many ideas and so many aspects there. I didn't realize there was all this work going on in the Highlands, and I think that's really important that we have to get that message out. But also, I'm really, really enthusiastic about the idea of more collaborations in the future. And there's so many different research questions that we could apply. So I hope this is just the beginning of a dialogue with you, Laura. But thank you very much for a really interesting talk.
Oh, well, honestly, thank you so much for having me. It's a real privilege, so thank you. It's really nice to get to talk about archaeology again, because I do seem to talk a lot more about geology these days.
Thank you. I'm going to stop recording now.